Hello, everyone, and welcome to this week's Client Tech Talk webinar. Thank you for joining us today. I really appreciate it. Our topic this week is hybrid cloud vision, and I know that many of you know who Evolving Solutions is. You're either existing clients or have joined one of our webinars before, but I wanted to quickly give you some background for anybody who might not be familiar with us. So, Evolving Solutions is a technology solutions provider. We help our clients modernize and automate their IT and support their business transformation. So what that really means for many of our clients and what we've heard our clients ask for over the years is we're moving into this new era where we have a lot of the cloud capabilities as well as other kinds of modern capabilities that have come from the cloud environment, being able to operate both that cloud environment as well as your existing data center with a similar set of tools, with some similar process, and with some similar people is an important piece of work that many of our clients have asked us to help them with. And so we call that modern operations. It stems from a variety of things, everything from developing automation to developing monitoring that works in both the cloud as well as on-premise, to things like data protection, where data protection may look a little bit different in the cloud, may look a little bit different than it does on-premise, but being able to leverage that same capability in both places is really critical. So today, I wanted to take a step back and actually provide a little bit broader context of what hybrid cloud architecture means for Evolving Solutions. And joining me today is Art Mills, who's our enterprise cloud architect. Don't let the name fool you. Not the art part, the cloud part, that we actually have a broader vision of cloud than simply what you might think of as traditional public cloud in either Azure or Amazon or GCP. So I'm actually just going to turn it over to Art and let him go into a little bit more detail about the hybrid cloud vision.
Yeah, thanks, Mike. As Michael has let you guys know, I'm Art Mills. My role is to kind of evangelize what the cloud can be for you within your enterprises, and what the cloud maybe should be. And we're talking about the hybrid cloud today, which a lot of you guys are going to be very familiar with, but we're going to kind of do a little twist on it to make this worth your time. So as a general rule, people now kind of understand that the cloud is not a place, it's a set of disciplines. And what we're trying to bring to people is to kind of understand what those disciplines are, how you can deliver them to your customers. And the underlying infrastructure is critical, but it becomes more like electricity. It's a light switch that provides the platform by which you can deliver a set of disciplines to your customers that lets them do what they want to do. It's not just somebody else's computer anymore, which is what many people have always considered the cloud to be. So what do we consider those disciplines to be? And this is not a surprising slide. You can go onto the internet and find these basic principles, these basic disciplines of cloud computing yourself, but you must be able to deliver on-demand service. This means that if a customer wants to do something, they can do it. They can hit buttons, they can create an idea, they can play with the idea, they can use it how they need to use it without a lot of back and forth with operating staff. This is a critical reason why many customers are already moving to the cloud. People are using their credit card and simply going to Azure and spinning up development environments because they can, and they can do it so quickly, it makes sense to them. It's not a really good business model. It doesn't really help the operations team control what's on there. It doesn't translate well to making it a production environment, but it's something they can do on their own, and it's a really big driver to why people are using the cloud. It's got to have broad network access. This means that if they want to have an app that has a database in the back, they can access it. If they want to have an app that has a memory grid or a message queue, they can access it. They can spin it up. They can connect to it. They can utilize it. And again, with the same principles on demand, they must be able to do it quickly and easily. To optimize what you're doing, you need to pool the underlying resources into a kind of a platform that allows multi-tenancy within your organization. Whether it's by application or by business units, you must have a number of different things working within this kind of cluster of machinery, allowing multiple teams to work within it individually on their own without interfering with the other people. And whether you do this by application or business unit or even by environment, dev, test, stage, QA, whatever, you have to be able to provide that to people. It's got to be able to rapidly scale. And the The scaling, most people consider scaling to be, I have a very large event. I have a lot of customers coming on. It's payday. They want to see what their statement is. They log into the site on the 15th and 31st. That's great. If you can scale up, that's wonderful. But if you scale up and you stay up, your costs are going to go so high and you're going to have so much underlying equipment, it's not going to be very good for you. It also has to scale down. You have to be able to trigger events that bring it back down to an easy, efficient level of performance. And again, it must be measured. You must be able to say, this group is using these resources, and for IT organizations that are lucky enough to have one, charge them back, or at least show back what they're using so they understand the level of commitment you're providing them and what you're giving them to perform the business function that is critical to your organization. If you do these things, you have essentially achieved cloud computing. So if you're in Azure, if you're in Google, if you're in AWS, this is what they're giving the end user with the credit card. This is what the cloud really kind of is. So what then is the hybrid cloud? How do we think about the hybrid cloud? And most of us kind of know these things. We've seen these things. We understand it. Microsoft's version of a hybrid cloud is a computing environment that combines a public cloud and a private cloud by allowing data and applications to be shared between them. This is not surprising. It is also not surprising that Microsoft's version of hybrid cloud, they happen to sell Azure. So they'd love to be the private part of, or the public part of your public cloud combination, right? Red Hat, very similar look. It's a hybrid cloud. It's an IT architecture that incorporates some degree of portability of your workloads, orchestration and management across 2 or more environments. Red Hat also has a great product called OpenShift that is very, very good for providing that exact definition for what a hybrid cloud is for them. IBM, I know this is a hard one. IBM does have a cloud. Please stop laughing. It's important to know that there's a cloud here. But IBM's version, and it's a very good version. It's a hybrid cloud. It's a computing environment that connects a company's on-premise private cloud services to a third-party public cloud, kind of like Microsoft's, with a flexible infrastructure for running the organization's applications and workloads. Very, very similar to what you can see everywhere out there. And these are all common definitions. These are all things that we're all very comfortable with. And what do we know of when we think about the hybrid cloud? We think about connections between one or more physical location. We think about the portability of workloads, the ability to bring something from the public cloud to your private area or vice versa, and to be able to run it where it's optimized for the customer that's connecting and for your business. We need orchestration and management across those locations. It's not enough to just be portable. You must be able to have visibility into and observability into what's going on wherever the application happens to live. Commonly, one of the locations is thought to be your data center, your legacy, place. One of the locations is generally thought to be a cloud provider, something very, very modern. And all of this is right. All of this is meaningful. There's nothing with any of that any of you should take away and say that's wrong. It's all right, but all of it misses the one key element to what makes cloud computing and what makes hybrid cloud computing. How do you do your work today? If you're thinking about the hybrid cloud and your current thoughts are that you're going to do your work in your private location one way, and you're going to do your work in the public location another way, you're probably never going to achieve hybrid cloud, even if you achieve portability, even if you achieve the ability to kind of view into what's running in these locations. So what I consider the hybrid cloud to be, what I'd like you to consider the hybrid cloud to be, is the hybrid cloud is delivery on a decision to allow internal customers to experience the same disciplines and outcomes that they experience in the public cloud within areas you operationally control. So what does that mean? If a business wants to develop a new application, let's assume it's an incredibly simple application. We're not going to go very deep into this, but let's assume they want to do a brand new application. It's going to have a front end, some kind of a web application on the front. It's going to connect to something on the back end. Let's say they want to have a Redis in-memory data grid running in the background. They want to have a daily poll to ask customers what they think about something or another, just for interactivity to see who's looking at their website. And they want to see what this looks like in development. Okay, that's all they want to do. This is not a very complex request you might receive in your environment from your dev team as an operator. How does your workflow start in your legacy enterprise environment right now, in your data centers right now? Is it this? Do you tell your customers, submit a ticket? Look, I've been in operations for a long time. I think there's people on this call. If Joe's on this call from Allianz, if Jonathan's on this call from Allianz, I think at Allianz, I had the printed sign in the cube saying, don't come here unless you have a ticket, right? This is a completely normal way for an operator to think. Give me a ticket and I'll do the work. So what would that look like in a typical environment? There's 2 new VMs. You need to have access to each box. The people requesting are going to want to access. You need to have middleware on the front end. So you want Tomcat on the front end. You need to have middleware in the back end. So let's say that's Redis, right? We've already decided that. You need to have a DNS entry that allows the public to get to the front end web server. You need to have a DNS entry that allows the internal web server to connect to the back end web server. You need to have firewall access that allows external users to the front end. You're going to have firewall access that allows internal access to the back end. This is, again, pretty straightforward. We understand the workflow. How long does each step take in your organization? How many tickets does it take to accomplish this? Or how many steps within a ticket does it take to accomplish that workflow? How many teams does it cross? How many different silos in a legacy organization does this simple request cross? Well, let's try to map it out. You're going to have to submit a ticket. It's going to go to a server team for one of the VMs. You may have a very strict environment with your change management team. You may have 2 tickets to accomplish the same thing. Well, you're going to have access on the box. So that's going to go to somebody in security, right? They have to approve access to the box, or they've got to approve a never-ending password for a service account with an AD, right? They've got to do something there to make sure that they can trigger that. Some app team somewhere is going to get the request to install Tomcat on the front-end server. Some app team is going to get a request to install Redis on the back-end server. The networking team is going to get a request to say, hey, give me access from the outside world to this box so that people can actually hit it and interact with it. And obviously, if you're going to do it from the outside, you're probably going to have the security team involved to make sure they understand it and they're good with it. You need to have a DNS entry for the internal boxes to communicate. That's probably a little less rigorous, so you might not have security involved in that. You need to have a ticket for the networking team to open a firewall port from the front end to the back end, which is probably going to involve the security team. This is a new thing. People are going to access it. They want to know about it, right? You need to have some kind of networking team or DNS team or somebody control the firewall for both of those things. So how many steps is that for a very, very simple concept? It's at least 8 steps, maybe 12. How many teams does it cross? At least 4 teams, maybe more if your networking team is brought up in firewall and load balancer and other things, right? And this is such a simple idea. We didn't ask for storage, so we didn't involve the storage team. We didn't ask for a database. We didn't involve the database team. We didn't ask for a load balancer because we're not worried about scalability. We didn't worry about high availability. We didn't ask for certs. This is the simplest thing you can do. We didn't ask for any other environments. We asked for this one simple thing. These webinars aren't great for kind of interactivity, but how long in your environment does this take? From a customer's request for this simple procedure to be delivered to the customer so they can immediately begin working on it. Does it take 2 weeks? Does it take more? Does it take less? I've been in organizations where it takes the delivery of a VM to start the next process can be measured by a sundial. This is not a good look. And so if you have a choice between sundial delivery of a VM or taking my credit card out and going to AWS and getting 300 VMs however I want, what are you going to choose as a user? As an operator, you're going to want them to choose you. But if you can't deliver it because of the rules and bureaucracy within your organization and the change management, they're going to go somewhere else. And you're going to hybridize a thing you couldn't build yourself and you can't measure yourself. So, oops, go back here. So what is cloud-like about this workflow? Is there anything cloud-like about this workflow? Let's imagine you have no local data center at all. Like you have nothing that you're in charge of, and that every single thing you do is in Azure or AWS or GCP. If you did this exact workflow in the public cloud, are you getting any of the benefits of the cloud? So if so, how could you get any benefits of a hybrid cloud if you're doing all of this on your prem, but you're not doing it for your cloud workloads? It should look like this. This is the cloud. This is also going to be your hybrid cloud. You're going to give these things to people in a way that they can achieve exactly what they want to experience in the ease of a public cloud within your local environment. You're going to change kind of what you're doing as an operator to kind of provide that platform to allow these things for your end user to experience the same things they can get with a credit card somewhere else. You can't accomplish cloud computing following typical legacy workflows. You can't have rigid change over every single piece of every single thing you do and achieve cloud computing. You just can't do it. So in a perfect world, how many tickets should the request we just saw take? How many teams should it interact with? It should take 0 tickets. It shouldn't require any tickets at all. And it should require 1 team interacting with it. And that's the requesting team. And that is the key to understanding how we want you to think about kind of delivering a hybrid cloud. So while this is conceptual, let's give a quick example. And there are many, many ways to deliver upon this how, changing your operating model to be this. One of those ways, and I have to kind of get out of the slideshow here real quick. So let me do that so I can move over something else. And end slideshow. And I need to bring this over. And so in this case, I'm running what is a simple Kubernetes cluster within Azure. And what I want to show you is a way that you might think about this being delivered on-prem, because you can run Kubernetes on-prem, you can run it anywhere you want. That same application can be described in a simple file, a YAML file. It can be described as by name. It can be described how many I want. This is how many web servers I want. It can be described by what containers I want running inside it. I want a Redis container to be pulled from an image repository. This is what infrastructure as code is. This is simply somebody writing this file. It's going to bind to Redis. It's going to bind to some custom image that they've made themselves within the development team. It's going to deploy this in some way, shape, or form in a very simple way. So I'm the developer now. I'm no longer the operator. You, the operator, have already provided me my hybrid cloud. I'm working how I want to work, right? If I then come into here and I type, and I've already cloned this down to this workspace, so it's going to be easier. Right? I'm going to apply that file I just showed you, which is in that directory on my computer, into a namespace called demo, right? When I do that, I'm creating a number of things that are going to be part of this namespace. This namespace with that file has created 2 pods because I told it to. I told it over here, I told it to create 1 of these. I told it to create 1 of these, right? It's going to create 2 pods. It's going to create 2 deployments. That file happens to have 2 different deployments, just separated by some dashes, right? It's going to create load balancers. This is the external access I need, right? It's still being built in Azure right now. It'd be being built within your cluster, whatever you're using, right? And I need to have an access to the backend, which is going to be here. So pretty quickly, and I'm pretty sure it's already ready, but let's just see here. So yeah, so it's already ready now. So if I see here, what I have is I have an external IP address that's been given to me. My platform is set up so that it works how I want it to work. And there it is. I have a very simple voting app. Obviously, the people on this call, we're all very smart people. We're all going to vote for dogs because dogs are cooler than cats. But we're going to vote for this today, and it's going to be in persistent memory, and it's great. I was able to accomplish this with no interaction with operations. I'm a developer. I know that Redis is available as created and maintained by the company that makes Redis. I wrote this front-end web page that I wanted to have. I put it in the image repository. I wrote a YAML file, or I could hand you a YAML file, and I said apply it, deploy it, run it as part of a pipeline. And then it's there. I've given the ability for my end user to interact with this in a completely self-contained way, to to do his work how he needs to do his work. I've given him a namespace he has control of, in this case, demo. And I've created this application very, very quickly, very, very easily. This has the ability to do anything I want it to do. If I want to quickly scale, not that I need to get too deeply into this, but if I want to do kubectl, because I'm all of a sudden running this, and it's running into problems, I just simply replicas 5. I'll make it. So I've scaled now the front end of my application where we just went to. So let's say if I get all from my namespace demo, notice now I have 4 new pods, 1, 2, 3, 4, that have been running for 9 seconds. I've scaled it up. Again, I don't have any interaction with the end user. I don't have a change ticket that is required to make this happen. I'm simply able to do whatever I need to do to develop my application, to test my application on my own, because you as the operator have given me an underlying platform to do that work. And obviously there are more mature ways to kind of handle that type of thing, but that's what we're talking about when at Evolving Solutions we consider, what the public cloud is. So I come back to this presentation.
Well, can I ask you a couple quick questions, Art?
Yeah, please.
So a couple things that you touched on, I maybe wanted to ask you to elaborate on or whatever else. One of the things you mentioned is, for example, using a Redis database. One of the values of, we see in public cloud too, is, or one of the, I should say, ticket generating events that happens inside of a traditional data center is that's not on our standards list. I'm in a public cloud, I'm going to go out and grab it because a company called Redis made an image available for me. How have you seen people sort of start to try to integrate that into their enterprise standards or their enterprise architecture? In other words, maybe it's a huge question, but maybe a couple of words on how this kind of approach, hybrid cloud, changes the way enterprise architecture happens because of those kinds of things.
Sure. And again, I think that it depends on what type of organization you're in, right? As a general rule, an enterprise architect wants any solution that works to fit the request. Typically, an architect is going to be very, very open on developing a solution. Standards typically come from another group called security. So security is typically a little bit more difficult to work through. Security typically has more rules and more hurdles to jump through. You simply have to make a decision in this kind of world, especially where you're allowing self-service of things. If they want to test Datadog, they want to test some other observability tool, and yours is App Dynamics, and they want to test something else, they have to have the ability to test in some environment. That has to be just kind of understood and nodded at and granted. Now, before it gets graduated up the chain into real environments where real customers can see, yes, you still have to have the same enterprise level legacy conversations you've always had to have. You have to have a negotiation with somebody on other teams to make sure they understand that I'm not going to handle this part of the data, even though we have a corporate standard that says all data must be put into a relational database. Well, no, I want to run this in-memory data grid up to 2 gigs, and then I'm going to flush it every day and then get rid of it, right? It has to be understood that the negotiation still happens, but it happens after the work and evaluation is done. It doesn't happen before you start work. And often in enterprises, it typically, unfortunately, can start before work gets started. You can't even look at this because we have this. And you get blocked by policy before you get blocked by the reality of the thing you're trying to evaluate not working, right? That's why proof of concepts as a general rule in enterprises are so important, because you have to prove it. This is the same thing, just in a lower environment.
Awesome. Thank you. Appreciate it.
Sure. I think I only really do have one more key slide here, right? And that slide, I think, is that the hybrid cloud requires you to also avoid the typical legacy workflows, the hurdles that are put in place in a standard enterprise. You still have to have a team that is capable of building an environment that provides these 5 key core principles. That team doesn't have to cross other teams to do it. That they may have to cross teams to build it, but they don't have to cross teams to maintain it. They don't have to cross teams to allow the underlying customer to utilize it. That team kind of changes from a standard sysadmin to something that is considered, the site reliability engineer, the SRE, which is a Google thought, but you almost have an admin stop being an admin, stop reacting to tickets, and start proactively providing an underlying platform. They almost become a developer. They just become a developer of things that matter to the core of the business versus the outside customer of the business. They write files. They'll become YAML jockeys, right, versus ticket jockeys. but at least there's something interesting in that, and it's controllable, and you always know what you're seeing and what you're doing, what you're deploying, and it will be the exact same. I can't tell you how many times as an operator we've promoted something from dev where devs get to put it out there, and then maybe they even get to do stage, but then when it goes to prod, they can't touch the prod servers. Only I can touch the prod server. We've never seen the app. We have no idea how it interacts. We have no access really to the dev boxes, which they put a whole bunch of things on that we didn't know about. You get to prod, the boxes don't match. The code may match, but the boxes don't match. There's an interaction there that is negative. You have to troubleshoot it on the fly during a 24 or 48-hour release party that you get to do every 6 months. And you bring in this great food, and that's wonderful. So keep having your every 6 month party. Just make it be we're doing so great party instead of a release party, right? Release daily, release every minute, right? The infrastructure should be reliable and resilient enough to be able to provide the end user the ability to work on it all the time without you ever having to worry about anything being different. There's no underlying access. They can't log in and break something. You're not giving them access to that level. You're giving them access to put a bundled batch of software that they control and you don't care about onto a box you do control and they don't care about, right? and that honestly that's kind of DevOps in its perfect world. In DevOps, one group dev is making ops kind of work like dev does, and ops don't want to, or one group ops is making dev work like ops does, and dev doesn't want to. Really, in DevOps, what you're trying to do is you're trying to have operators provide an environment where devs can be devs and not care about the operation, and they don't really want to. And you also, as an operator, don't want to be a dev, but you're providing that environment in a way that the devs can access, right? You're still two different groups in many cases, but you can do that.
So one of the questions came in that I wanted you to maybe weigh in on a little bit. You showed the example of getting to sort of the 5 characteristics of cloud computing that was based off of Kubernetes, and I think we all know Kubernetes sort of provides a lot of those things built in. Is that the only way to accomplish this, or can you accomplish something like this using VMs or using other kinds of platforms?
Absolutely. So automation's automation, right? There are 100 tools, Chef, Ansible, Puppet, Terraform. There are many, many ways to automate your underlying infrastructure, your underlying VMs, to do essentially this, and to very quickly build out some kind of front-end API that would allow somebody to kind of go into and do that. You don't need Kubernetes to do that. The advantage to Kubernetes is that somebody else has written the 30 or 40,000 lines of scripts that you don't need to now. And remember, VMs back in the early 2000s, there was a real fight between whether you want a physical server or a virtual server, right? And that fight was won eventually by VMs, and VMs became the standard. VMware has yielded the standard to containers. They're going to build container native software, right? Where containers live on their hardware, right? There's no more VM. There's just containers running on bare metal. So it would behoove you, knowing that your largest VM provider is doing this, to consider an environment like Kubernetes, because it's so much easier for you to consume, because it's had 5 years of this incredible community growth to be able to do this for you. But no, you can do it without Kubernetes. But because Kubernetes is free and it's accessible and it runs everywhere the exact same way on every single bit of hardware, no matter what you're running everywhere, it becomes a very attractive option for people to accomplish this.
So another question that sort of popped in, is it worth doing this for all of your applications? And is this about, is it worth building this ability into my legacy applications? Is this exclusively an application migration problem?
That's a great question. And unfortunately, too many people feel that this containerized world is optimized and only for modern microservices, and those kinds of things. And it is true that this world is optimized really nicely for that. What's false about that is, and many people don't understand this. Again, I'll point out, if Jonathan and Joe, who are from Allianz and I worked with there, are on the call, about 70% of the applications that the core underlying infrastructure team runs can be containerized tomorrow by the vendor giving you the container and putting it into a Kubernetes cluster tomorrow. And you get all the benefits of scale and redundancy and HA and availability zones that get built into that kind of platform, right? And so when you, about 3 years ago, when I was at a company called Pivotal, we would go into a place and we would try to meet with devs and to tell them, this is how you want to work in the future. The apps guys don't understand it. It doesn't really benefit them. And that was kind of true then. But as Windows 2019 has matured and become more basically Linux, and you get the same benefits of the Kubernetes cluster across Windows nodes and Linux nodes, and especially as Kubernetes is bringing in more Windows AD features, you're seeing that gap become where I would actually probably go into a company and say, let's not worry about devs. Let them do whatever they're doing. Let's turn the Elasticsearch we provide to them from 15 or 20 VMs to 3 running 20 or 30 containers, right? Let's turn your antivirus into this containerized thing. And it's almost certain, SQL, Mongo, it's almost certain the applications you're running already make the container for you as the app team to deploy. And so let's go do that. So yeah, I tell people that I think 70% of their current environment can almost overnight be transformed. Just go check your vendor. The other 30, there's going to be a combination, right? Some of it can be, some of it can't be, but you're inventing the container, which can be harder to maintain, and maybe it's not worth it. Maybe you just time that out, right? Over time, that becomes gone, right? Start with the easy and then go to the hard. So.
That makes sense, and I think that's our approach to a lot of these modern operations capabilities. Start with the easy, show some value, and then dig into the things that are a lot harder to get into. So, exactly. Thank you, Art. I appreciate this. I thought this was incredibly great perspective. You've shared this with me before, so I had a little chance to preview it, but I really am profoundly appreciative of this approach to hybrid cloud. We take the location out of it and start talking about how we do work, and it very clearly is something that we all need to sort of get our heads around and progress with.
No, I agree. I mean, I think that one thing I've said before to people is that this version of a hybrid cloud doesn't require a public cloud at all. It doesn't require any more than one location. It requires the one location that you want to make hybrid cloud. Because what you're doing in the hybrid here is you're not worried about portability in the case of one. You're worried about how. You're worried about making it feel like a public cloud feels to the end user. And so it kind of changes how you think about approaching it. And if you approach it this way, it becomes very, very easy to consume services wherever they are.
Absolutely. All right.
Well, yep, I think we have just 2 more slides about our future, right? This is BU. So.
Yeah, absolutely. So thank you. If there's any questions in the next 30 seconds or a minute, go ahead and pop them in. We'll be happy to go back and answer them. I appreciate everybody joining today. I appreciate your interest and your attention. And I appreciate Art taking the time to pull this together. This is really a great, like I said, I think this is a really great perspective and really well illustrates how an operations team needs to be interacting with hybrid cloud. I think we tend to marginalize the operations team sometimes. I think the developers get to have all the fun. We know that the operations team is a critical piece of making this happen for our businesses. So we have got a couple more webinars coming up in June. We've got next week, I'm going to take a break, and Phil Fisicella is going to, from my team, is going to join with a couple of our consultants and talk about VDI Day 2 and some client experience there and what the considerations you need to take for making that environment work. And then the last week of the month, we'll be talking about storage automation. So playing a little bit into what we talked about here today, the things that need to be automated to get that cloud-like experience, whether it's with containers or not. We've got some great experience across a variety of use cases that we're looking forward to sharing with folks that week. In July, we'll take a little bit of a different approach, and we'll be doing a different series based off of our technology day. So look for that coming forward, that series coming out in the next few weeks, and we'll look forward to having you join us then as well. So thank you, Art. Greatly appreciate it.
You're welcome. Yep, no problem. And no more questions.
And,
if no more questions, I'll end the slideshow. So.
Good. Thank you, everybody, for joining today. And look for a replay and a link to a replay in a couple days. If you've got any comments or feedback, we would love to hear it. Thank you.
Thank you all.